Okay, so it's 5 minutes past now, so I'm going to go ahead and get us started. Um, so thank you everyone for joining us for our workshop today, Visualizing the COVID Pandemic. My name is James Gordon. I'll be leading the workshop, or your host for this event. And we'll be going until around 11:30 today, and resume again tomorrow morning at 9 a.m. So as you all can see, as we all are these days, I am working out of my my home. So you're probably going to hear my children, my dogs, my spouse in the background. So that's just kind of the life we're living right now. But hopefully nothing will be too disruptive. Actually, you're probably not going to see my face very much. You'll hear a lot of me talking, but I'm mostly going to be sharing my screen. I've got some slides I want to get through, and a lot of what we're going to be doing today and tomorrow is looking at the actual interface that we're going to be using to create these cool charts. So I'm actually going to disappear now, so soak it in because it's going away. All right. Okay. Okay, so and so one thing I want to point out at the top, the slides that I'm going through are all available at this URL right here at the bottom. That's coviz.rji.events. So if I like go too fast or too slow, or you can just point your web browser at that address to see the slides that I'm presenting here. I guess before I get going, if somebody wants to like step into the chat to say if my voice isn't coming through, or if you can't see what I'm trying to show you, just let me know if anything's wrong right now. These webinars, I'm kind of new to them, and it's always like, I'm always like wanting more feedback than I'm getting to know if that I'm actually not just talking into a void. Cool. All right, seems like things are good. So, all right, so let's get started. Just to kind of talk through what we're doing here, we've got a few objectives we're going to try and get through before the end of this, before the end of the workshop. And the first is to just prepare available data for further analysis, and explain the sort of building blocks of visualization design, and compose ready to publish interactive charts. At a high level, like those are our three main things that we want you to be able to do before you leave. Your time is over with us. But there's like a lot in each one of these that we're going to dig into a little bit more. If this is roughly what you feel like you signed up for, then please stick around because that's what we're doing. Okay, so just to say a little bit more about who you're talking to, my name again is James Gordon. I'm a senior editor at the Reynolds Journalism Institute, which is located at the Missouri School of Journalism in Columbia, Missouri. So I'm a designer and a developer, a data journalist, and an educator. I teach data journalism at the Missouri School of Journalism. Before coming to RJI, I was a lead developer at a little organization called the California Civic Data Coalition. That was like a 2-year gig before I came to RJI. And before that, I was a grad student in the Mizzou School of Journalism. And then before that, I was a product manager for a political campaign technology firm in the Boston area. So I've like done a lot of stuff in the sort of space of like journalism and technology. I find that a lot of practitioners in this sort of area are have a lot of exposure to like lots of different fields. I certainly don't consider myself an expert at any one of these things, but you know, that's kind of just the nature of the profession that we've chosen. I also want to introduce Kat Duncan, the interim director of innovation. Kat Duncan and I together form the RJI innovation team. So Kat, I want to throw it to you to introduce yourself, if I can do that. Maybe I can just like give you the mic somehow. Hold on one second. Let's see. Okay. Sorry for I'm fumbling here, but just one second. I'm going to go to. Okay, so I think I'm allowing you to talk now, Kat, if you want to try.
Sure. Hello, everyone.
Thanks.
I just wanted to say hi, and I am here to help answer questions, share links, anything in the chat. If James is busy teaching and you missed something, please feel free to type it, and I will try to keep up with it. He will too, but I'm here to help, and I'm very excited to learn with you guys today, so I think it'll be a great workshop.
Cool. Thank you, Kat. Okay, so one other thing I want to throw out there before we get going is, you know, RJI's mission is to strengthen journalism in the service of democracy. And so within that kind of like broad mission, the innovation team that Kat and I are a part of is always trying to figure out ways of pushing the boundaries of what's possible and what we can imagine within the journalism profession. So sometimes that takes the form of tinkering with new forms of media technology, but also even more broadly, like sort of questioning some of the assumptions about the editorial and distribution processes we've always known. And so right now we're actually looking for journalists in local newsrooms to give us some insights into the challenges that they're facing. And so we've got a link to a survey here that we'd like you to, if you get a chance, just take the time to fill out. We'll be sifting through the responses and synthesizing some ideas, and hopefully embarking on some projects based on what we get back. And Kat's also dropped it in the chat if you just want to go there as well. Okay, so so the plan for today is to talk about this thing called first is talk about this thing called Observable, which is like the it's basically going to be like the water we're going to be swimming in as we do some data analysis and visualization. We're going to talk about the kind of context for the tool itself, the interface for the tool, and the syntax of it. And then we're going to do a tutorial where we make a little app that fetches us pictures of dogs, so lots of fun. After we kind of get a handle on Observable, we're going to move on to this other thing called Vega and talk about it in the context of something called the grammar of graphics, which is like a way of describing how visualizations are constructed. And we've got a couple of charts that we're going to be making, and then once we do that, we're kind of going to throw it over to you all, because we want to hear a little bit more about the charts that you all are interested in making. This workshop is sort of organized around the idea of visualizing the pandemic, and so we're really interested in any data sets out there that are connected to the impact of the COVID pandemic. You know, that the number of, it could be the number of cases in each state, number of deaths, the economic impact, you know, all the different ways that we are sort of measuring the ways that this big event is changing our lives and affecting us. So we have a few data sets we're going to introduce to sort of kick that off. You know, we also just kind of want to give you all some agency in what we're doing here, so that we can make sure that this is tailored to like what you all are trying to accomplish. And then, you know, for the second day, we've got a few more chart exercises we want to do. And that includes like making maps with Vega and building an actual chart builder, like a tool for creating charts that you can then share out to other people in your news organization and beyond. And then also how we kind of like concatenate and sort of layer charts together to make some really kind of grand visualizations that give people a lot of insights into the bigger patterns of the data sets. So a couple of other things I want to point out just at the top is that I've got some resources here that could be helpful for these exercises we're doing and beyond. One of them is a glossary of some of the terms that will be thrown around a lot here. So, you know, I don't really know what everybody's sort of level of experience is with working with data, with writing computer code, with working with JavaScript specifically. And if you don't have very much, wait, so somebody's saying the page is not displaying. Wait, do you all see my resources? Okay, so I'm sorry, is it, okay, yeah, you guys have the link, looks like, okay. I'm not gonna be able to always keep tabs on what's happening in the chat, but I'll kind of look at it from time to time. Yeah, the glossary is like meant to be a kind of place to see, to sort of get some definitions for some of the terms we'll be throwing around a lot. These aren't like textbook definitions, they're just kind of like the best meaning given the context of what we're talking about. And I'll be like sort of adding to that as we go. If there's terms that come up that seem a little bit confusing, or even if I get them wrong sometimes because I'm not a computer scientist, and so it's not always, the way I describe things isn't always the best. But well, I'll sort of like add to that document as we go. Another thing I want to point out is the COVID-19 resources that have been curated by the Missouri School of Journalism's librarians. It's a really awesome set of resources for tips and guides, data, contacts, all kinds of stuff related to covering COVID-19, including other workshops and the recordings of those workshops that we've done around this topic. So be sure to check that out in your own time as well. Okay, so okay, so I will post the link to the glossary here. It is just there's the glossary, and here's the link to the resources. Cool. Okay. Okay, so let's start now by talking about Observable. One of the things to note that was sort of a place to start is what Observable is for. And it is basically a composer of computational notebooks. And the idea of computational notebooks comes from this problem that was sort of recognized in the sciences called the replication crisis. And there's this really good article previously in the Atlantic about this. I'm actually going to pause my screen for a second. I think I'm having trouble with this browser I'm using, so I want to kind of switch real quick. I'm sorry for the interruption. Just 1 second. Okay. I'm going to start again. All right. Looks like you can, okay, yeah. So I mentioned this, this is like an article, it's a couple of years old now in the Atlantic about kind of the history of the scientific paper and how it's sort of outdated. You know, it's as an artifact of the work of science. You know, the scientific paper dates back to I think the 1600s, and you know, given the way that contemporary science is done with like really large data sets and lots of computation, the idea of like sort of a static document has not really been working for a long time. And so you've had a few efforts over the years to sort of reinvent the scientific paper into a document that can be more dynamic. And one of the more well-established versions of this is a tool called Wolfram Mathematica, which is, if you've, like, I remember like when I was in college, I had some friends who were like, you know, physics majors or math majors, and they were always talking about like Mathematica, which was something I never even had access to use. And so it's still a really popular tool in academia, but you know, comes with a like sort of hefty license, so it's not like widely used outside of the university settings. And so one of the more recent entrants into this area is something called Project Jupyter, which is a tool for writing computational notebooks in the Python programming language. I actually use Jupyter when I teach data journalism at Mizzou, because Python's a really popular programming language in journalism and beyond. And Jupyter's kind of creates, it has a sort of nice interactive environment that's helpful for people who are sort of learning code for the first time. But you know, the idea of a computational notebook is that it's a sort of document that's both an essay and a program. Like, it allows you to sort of mix together both prose and code into one document, which is, you know, if you're trying to do data analysis or data exploration, it's kind of better than this more traditional programming environments, which are more suited for software engineering, whereas computational notebooks are designed more for, as I said, data analysis and exploration. So there's a lot less of the sort of preoccupations with like, you know, lots of the things that go into like, you know, writing software that you would package for users or whatever. What I like about computational notebooks is that like I can kind of write sort of explanations in plain English and then have my code as well, and the output of that code, and kind of see it in real time as I'm writing it. You know, that's something that fits more into what journalists do when they are coding. We're usually not software engineers. We're usually just trying to like write some code snippets that produce some outputs or charts, or, you know, queries or answers to questions we're trying to answer. As opposed to writing a more like traditional code environment. So one of the things that I feel like this is really a great implementation of is this idea of like a data diary. You know, I come from this tradition in journalism, the computer assisted reporting, which has always sort of emphasized quantitative research methods, and the sort of borrowed a lot from the social sciences. You know, within that, there's this idea of like the your own sort of like personal document that you keep as you're digging into a data set that you can then share with somebody else. I feel like computational notebooks are like the best version of that that data diary, because not only is it something that is like easy to like write in, it's easy for somebody else to sort of take it and replicate what you've done before, which is a great sanity check before you go to publish. And so, you know, Observable is the latest and greatest version of one of these computational notebook composers. So I think we're going to see a lot of reasons why it's one of the best in class. And so let's actually just try it out right now. So if you haven't already, go to Observable HQ and create an account for yourself. And so I just created a new account for myself just recently. And you know, you have to, I think you have to have like a GitHub account or a Google account or a Twitter account in order to sign up. But once you do, you sort of end up on this landing page that has at the top a sort of set of curated notebooks, and then a sort of activity log of things you've done in the past. And so what I want to do first thing is create a new notebook. So there's like a new button up here. Everyone see that? Just click on that. And now we are creating our first notebook. The first thing you'll notice is that there's this sort of gray area right here at the top, and this is the bottom half of something we call a cell. Cells are like these sort of basic building blocks of notebooks, and they have two halves to them. The first half, the sort of bottom half here, is where you write code, where you can edit it, and then when you run that code, like if I hit this play button here, the output of that code is then rendered on the top half. So that's sort of one of the basic ideas here, is that notebooks are a collection of cells, and each cell has a bottom half where you edit code and a top half where you view the sort of output of that code. We can actually, if we want to hide the bottom half, the sort of code part, by unpinning the cell like this. And so now when now I can sort of click over here in the margin to sort of just see the output of the code if I want to. But if we can always reopen it later by sort of clicking in that margin. And if we want to just keep it open, we just need to be sure that pin is always selected. The first cell in the notebook is actually the title of the notebook, and right now ours is just called Untitled. So I actually want to change mine to, let's just change it now to first, like my first notebook. And so I demonstrated earlier how you can sort of click this triangle to run the cell. There's also a keyboard shortcut you can use, which is just Shift-Enter, which will run the cell. If you click the plus button, it will also run the cell and add a new cell for you to write more code. So now I'm going to write some, you know, when we, oftentimes in computer programming, like one of the first steps when you're learning something is to do the sort of hello world statement. That's what I'm going to do right now. I'm going to type the string hello world. So to do that, I'm going to do like a tick mark, and then hello world. And I'm going to be sure and close the tick marks at the end. So I've got tick and tick right there. So now I see this. Now I see hello world in the output. Another important point about cells. Let's make sure I'm getting through all my notes here. Yeah. So cells can have a name, and we can then use that name to reference as a reference in other cells. So what I mean by that is, you know, say that you wanted to type your own name into another cell here. I'm going to do that by creating what's called a variable, which is basically just another word for a name for the value in the cell. And I'm going to call it my name equals, And then I'm going to say my name is James. And now one thing I want to point out over here on the far right, you see these like 3 dots, and one of them is kind of a bigger dot. Each one of these represents a different cell in the notebook. You can see how they sort of highlight as I mouse over them. And the one at the bottom here is called my name, because that's the name we assigned to this cell. Now that that cell has a name, we can reference that cell in another cell. So if I go back to my hello world statement, I can now add in a reference to this cell. So I can say hello world space my name is, instead of like actually typing my name out here, what I'm going to do is type $, curly brace, and then my name, and then close the curly braces. So again, that was $, curly brace, my name, and then close the curly braces. I think there are people who use other names for these kinds of brackets, but I like calling them curly braces. So that's what I do. And so now when I run that, you see how the value assigned to my name is rendered into the string that is output in the cell above. We can actually do, in addition to like us just directly assigning values to names, we can write a sort of expression. So actually, before I do that, let me just back up for a second. So we talked about using these string values. We can use other sort of data types, including numbers. So like, I know it's really early still, but to be honest, I'm already thinking about lunch. So for this example, I want us to sort of declare a variable that we're going to call sandwiches. And I'm going to assign to that variable the number of, let's say it's the number of sandwiches that I think we're going to need for us all to all have lunch. I think we have 88 participants, so I'm going to say each one of us has 1 sandwich. So I'm going to use the number 88 for my sandwiches. And so now you see again, we have the name sandwiches assigned to the cell. I just noticed someone was asking, are there standardized sets of cell names? And the answer is no. A cell can be whatever name you want it to be. If you're familiar with other programming languages, like it's essentially a variable. Like you can use whatever name you want. One thing that I'll note that I just did a minute ago is that I'm using a kind of JavaScript convention called camel casing, where I use sort of a mix of lowercase and uppercase letters. One thing that you can't do when you're declaring a name or a variable is you can't have spaces in the names. Like if I try this, I get a syntax error because it doesn't, the syntax doesn't recognize this as one thing. It recognizes that as 2 things. And so, it's worth pointing out just right now, like, we just got an error message. We actually got 2 error messages, which is something that happens a lot when you write computer code. If you're sort of new to software development, but you're like, use a lot of technology, like, it often feels like really, really bad when like you see an error message. But when you become, as you get deeper into coding, like you learn to like really appreciate error messages as a form of feedback that helps you help sort of guide your work. I say all that because like I know that for myself, like when I was learning to code for the first time, like anytime I saw an error message, it was like I had failed or something like that. Like it was it was like the computer telling me that I was a screw up or something like that. And it's really like not a very like helpful way to think about error messages, because it actually is just a notice to you that describes explicitly like what you need to fix. And so, you know, if you do get an error message when you're writing your code, like the only thing you can really do is basically to take a breath and then read the error message and figure out what's going on. And you get better with that like over time. Like I understand that like as we encounter something like runtime error, my name is not defined, like when we see that for the first time, it feels a little inscrutable. But you know, if you just take a minute and think about what it's saying to you, it says, my name is not defined. That's because our little code snippet here is referencing something called my name, right? But right now, nowhere in the scope of our notebook do we have anything that is my name, like without a space in between there. We have this, which is actually incorrect syntax. It actually tells us that it's a syntax error. And so, you know, the error message always tells you exactly what you need to fix. It just may not be obvious that it's doing that the first time you encounter it. And so, yeah, to fix this problem, all we have to do is take that space out, and then now it's fixed. Yeah, as I was saying earlier, like this sort of camel case is kind of the JavaScript convention. If I were writing in Python, I would probably write it like this. With underscores, and you may actually see me doing that sometimes because I tend to write Python more than I write JavaScript. And so, but so this works just as well. Like the sort of camel case versus underscores, it's totally a conventional thing. You can use whatever you want, really. Yeah, to answer the question again, like variables can be whatever name you want them to be. Okay, so people are asking questions. Is the tick mark he used to use this? He said to use the same thing as an apostrophe. It is not, no. We'll talk about this a little bit more when we talk in more detail about strings, but you can use those apostrophes and quote marks to define strings as well, except not in this particular case, which will become more apparent in a minute. Anyway. Any other questions I missed? But what is the tick mark I'm supposed to use? I'm gonna drop in the chat. It's this character right here. It's the one that's on the same key as the tilde key. At least it is on my Mac laptop keyboard. Got it. Okay, cool. Yeah, and I know like I'm kind of like just kind of like bouncing around a lot of terms right now and like a lot of other things, but we're going to go into a lot more detail about JavaScript syntax, possibly more detail than some of you are ready for. It's like the cool thing you'll see about like computational notebooks and Observable in particular is like you don't actually have to know that much code to do some really cool stuff. But you do have to get like sort of basic syntax stuff correct. And it just takes a little bit of practice to do that. And we're going to do some of that practice together. Okay, so I was mentioning sandwiches, right? So we create a variable called sandwiches, or a cell with the name sandwiches, and we assign the number 88 to it. We can actually use that cell or that value in other cells, like I mentioned. Like say we wanted to calculate the total amount of money it would take for us to buy all the sandwiches we needed. So we'll sort of create sort of expression here called total and make that equal to the number of sandwiches. And so one thing I want to point out, like as I'm typing here, you notice how the word sandwiches shows up here? That's because there's a thing in the scope of this notebook called sandwiches, right? It recognizes that name sandwiches. And so we don't actually even have to type the whole word. We can just hit the tab key and it will fill in the rest of it for it, because Observable can recognize, oh, there's something in scope here named sandwiches, or something that's, there's only one thing in scope here that begins with an SAN. And so obviously you want to type the word sandwiches. So that tab completion can be a real time saver, and actually can be sort of a guide to you when you're writing your code, when you're trying to figure out the exact name for certain functions or variables or other things that are sort of like in the scope of your notebook. Let's assume that the cost of a sandwich is $5. I'm going to get the total, I need to multiply the number of sandwiches by the number 5. So the operator for multiplication is the asterisk. So that's the shift and then the 8 key on my laptop. And then I'm going to type number 5 and boom. Now total is equal to 440, which is 88 times 5. I'm assuming. Okay, somebody's asking about problems with global and let and var and const and all that kind of stuff. Okay, so we're gonna get into that a little bit as well, but basically, no, like this name that we use right here at the top of the cell, and so let's actually see this right now. If we decided to, that we wanted to change the value of sandwiches. So like, let's say we wanted to actually let the user edit or set the sandwiches value themselves without having to write any code. One thing that's kind of cool about Observable is we can actually do that by presenting the a DOM element, like an HTML element that lets the user edit that particular value. That is done using the keyword view of, which is a special observable thing. And I'm going to set view of to be sandwiches equals HTML and then I'm going to do another tick mark, and then I'm going to do caret input. Sorry, just one second here. Type range. And then close that. Did I do that right? Yeah, I did. Okay, so again, so now we get another runtime error, and that's because Observable will balk at you if you try to have 2 cells with the same name. It even tells you that. It says, hey, like sandwiches should not be defined more than once. That's kind of one of the ways that it handles this idea of like globals. But you can actually have like locally scoped variables as well using let and const. And we'll see how we can do that here in a little bit. So somebody's asking the question, are tick marks only needed around text and not numbers? Yes, that is true. So this is another sort of like syntax thing we're going to get into, let's actually kind of finish this exercise real quick, and then I'm going to talk more about that. To sort of fix this problem that we have right here, what I'm going to do is just go up to this cell and delete it. Delete. And so now that error goes away. As you can see, like I can actually edit the total, but by sort of changing this this slider here. And what that's actually doing is it's changing the value of sandwiches. And we can see that if like I have the word sandwiches here. And so I can see what the value of sandwiches is right now. So right now it's at 74 versus 83 and all that. And this is kind of one of the cool things about Observable compared to other computational notebook environments is that like all the cells are sort of reactive to each other. As I mentioned, cells must be unique. and we'll talk more about what makes that reactivity like really cool in a minute. You know, first, before we move on though, like now that I've like created my first notebook, I want to actually publish it for the world. I know it's not very much, but it is my first one, so I'm proud of it. One thing to note is that all the books are private initially, and in order to make them available to other people, you have to sort of publish them using this button right here. And so now everyone can see my code and my output. You know, if I wanted to, I could actually edit it to hide the code if I wanted to. But even if I do that, other people can come along and like see what that code is, which is of course no problem at all. So one of the things that I wanted to point out about Observable is that like it's not only this environment for like writing computational notebooks, it's also this platform where you have lots of people writing notebooks and sharing notebooks and taking each other's notebooks and kind of like forking them and collaborating on them. One person that is a really heavy notebook user is Ben Welsh at the LA Times, who runs the graphics and data desk. Ben and I were collaborators on the project that I worked on before I came to before I came to the Reynolds Journalism Institute. He teaches a class at the at NICAR around Observable, and you can go and see like all the notebooks that he creates for projects and graphics that he works on at his account. His handle is PaleWire. And you'll see some from other journalists, the New York Times, really all over the country, all over the world. This is becoming a pretty popular tool in this sort of graphics and data space. Let's keep moving. All right, I sort of mentioned that the code that we're writing in Observable is JavaScript, which is like, you know, it's the native scripting language of the web. It's the code that makes web pages interactive, but it's actually not exactly JavaScript. It's sort of JavaScript with a few changes that are, and we talked about a few of them already, but they're really well described in this notebook that kind of talks about like all the different some of the key differences between observable syntax and just vanilla JavaScript. And so if you're interested in digging into some of the details about that, be sure to check this out. What's cool about it being in JavaScript is that not only is like a language that has a lot of, it's very popular and some people are already familiar with, like, it gives us access to a lot of libraries and visualization packages like D3 that are available to us to like import into our notebooks. And so it makes like the sort of the coding environment like really extensible. Let's actually kind of dive in to get to more detail about this sort of syntax of Observable. If you could each go to this notebook here, I'm going to just drop the I'm going to drop it right here. You know, what I'm going to do is demonstrate how we fork a notebook as well. Okay, so I'm going to go. So I'm going to install that same URL. Okay, and so now, so this is a notebook I published like earlier, but I actually want to take this notebook and fork it under my account, so that now when I look at my notebooks, I see the one we just made, like a test one I made earlier, and this other one, which is sort of, has this sort of icon next to it indicating like this notebook was originally composed by under a different account, but you've made your own copy for your account. This idea of forking is connected to like version control. If you have any sort of developer friends, you may hear them like ranting about Git or GitHub sometimes. That's sort of sort of area of concern that this idea of forking comes from. Somebody's asking what fork means. It's basically just to make a copy of something. Like if you imagine a document like having a sort of like linear history, and you're going to like take at one point just sort of take that document and sort of like branch it off into you're basically sort of like taking the document and like copying it under your account so that you can make some edits to it. And so now you've got like a sort of separate branch of the document's history. I think one thing I kind of glossed over earlier is that like you can actually go back and see the version history of a document. If we click under, so if I went back to my first notebook, and under this these three dots here, there's a view history button, which shows me like all the different changes I've made. Those changes are sort of showing up here on the right-hand side. This sort of activity in the notebook, which can be nice if you you know, make mistakes and kind of want to go back to a previous version. Okay. All right, so I made this fork of the notebook for me to work on. And so this has like a lot of the syntax of observable that that is going to be necessary for what we're going to do in this workshop. But I just want to say at the top that like this is not like a full on like dive into like all things JavaScript. But that actually is kind of good for our purposes, because you don't actually have to know that much JavaScript to do some of the stuff we're going to do in this workshop, and it's pretty cool stuff. We can get by on just kind of writing some basic expressions and learning how to interact with other libraries and software packages. So you know, one of the things that you know, we can do in JavaScript is deal with numbers and math. And so a number is like one of the most basic data types in JavaScript. And so to type a number, you can just type in, you know, whatever the number is, like 2 or 20 or 200,000. One thing you'll notice is this sort of / and then like some text here. What that is it's a comment. So it's like it's sort of text that's in the code that isn't read by the JavaScript parser. It's really like a way for me to write notes to another programmer who may be reading this code. These are notes that are sort of ignored by JavaScript whenever it runs or executes. So you can actually just kind of delete this stuff if you want to. A helpful keyboard shortcut is if you use the if you do control or command and then slash. So that's the slash that's below the question mark key on my my Mac laptop. It will automatically add the double slashes to denote like a code comment. So yeah, we can type a number here. We can also type not just integers, but floating point numbers. So for example, like 0.5, and JavaScript understands those numbers integers and floating points as sort of being the sort of same class of like numbers. You can also do numbers in scientific notation. So like if you have like a really, really big number or a really, really small number you're working with, like for example, if you were working with like a sextillion, which is like a 1 with like 21 zeros behind it, then you can, you know, it will, you can type all those out, or you can also just type in shorthand if you want to. So E plus 21, and it recognizes those as the same thing. So when we mix together numbers with arithmetic operators, we basically do math, basic arithmetic, right? And so all the, you know, the operators that you're familiar with from like grade school math are all available to you in JavaScript, plus some other ones that may be a little bit less familiar. So, you know, we can add numbers together, we can subtract numbers, multiply numbers. We can also raise numbers to an exponential power and divide numbers. The percent sign is an operator is used to like get the remainder from dividing one number by another. So like if you try to say we were going to try to divide 13 by 5, then the value is 3, right? And so one thing that's worth being explicit about is that like when you form an expression like this, like it should always, like, it will return like a value, and then like basically an expression is like evaluated and then can be used in like other parts of your code. Okay, so that is basically numbers and math, pretty straightforward stuff. So moving on to one of the other data types that are one of the basic data types in JavaScript and other programming languages is the idea of booleans. So this is like whenever you have a value that's either true or false. So in JavaScript, we just type those with a lowercase true or a lowercase false. Those are Boolean values, named for George Boole, the famous English mathematician. We can also do, when we do sort of comparison, that will result in a Boolean value. So like say we wanted to test whether 5 is greater than 4. That returns a Boolean value of true. There's also greater than or equal to, less than. So like if we typed a statement that was like logically false, right? It's going to, like 5 is not smaller than 4, then it will turn the Boolean value false. Yeah, greater than, less than, equal, greater than or equal to, less than or equal to. There's also like this idea of like strict equality, which is not something that we have to worry too much about, but it is another operator for doing comparison in JavaScript. Okay, somebody just asked the question, how much do spaces matter? And the answer is they don't really. If this were Python, I would tell you that white space matters a whole lot, because it's really indentation that matters in Python, but we're not doing Python, we're doing JavaScript. I just kind of like to use spaces to like just kind of make things more readable. So readability does matter in any coding language. Okay, so we talked about arithmetic operators and comparison operators. So now I want to mention logical operators. So that is when you are sort of testing sort of two expressions that evaluate to true or false, right? So, in the way Boolean logic works is if we, something can be true and true, ampersand true. If something is true and true, then it is true. If it's true and false, then it is also true, or true and false, then it's false. I always get my Boolean logic confused. If it's true or false, right? And so the logical operator there is the pipes. Then that is true. If something is false and false, then it is false. Definitely false. But in addition to just like writing, like it's not just a matter of like explicitly writing the Boolean values. Like if we had sort of expressions that we were testing, right? So if I wanted to know if 5 is greater than 4, which is true, and 5 is greater than 3, then that evaluates the true because both of these things are true. So you can use logical operators, like if you have to sort of do, if you're testing for like conditions, whether like multiple things are true or one thing is true but not the other one. That's what those are used for. Okay. Moving on to strings. So we kind of talked a little bit about them already, but basically a string is just a sequence of characters. It can be a letter, a number, an emoji, anything that's just like a bunch of characters that can form words or sentences or paragraphs or whatever. So a string value always needs to be wrapped in single quotes, double quotes, or backticks. So like going back to the previous example, like if I type my name, James, that works. This also works. The tick marks also work. But what you can't do is like mix the two because that will cause an error, right? One thing, actually I haven't tried this yet, but I'm pretty sure works. Like say our string had an apostrophe in it, we would need to be sure to escape that apostrophe. So the parser wouldn't read that as like closing the string. So like, if I wanted to reference, James's notebook, we would need to escape that. Otherwise, it's just going to think that, the string ends there. Like we can't just do it like this, right? Because then it's looking for the beginning of this string in front of the note. It's looking for the apostrophe in front of notebook. So that slash mark is how you do escaping. So we can also concatenate two strings together using the plus sign. So if I were going to concatenate my name, I could do it just like this. And so it kind of shoves the two things together like that, right? But we can also, I can add a space there to fix that. So I'm going to assign this string to a name called my name. And so strings can also have, really any sort of data type has properties on it. And one of the properties of a string is how is its length. So if I wanted to know how many characters long my name is, I can use the length property to tell me that. And I don't know if you noticed, but like when I added that dot at the end there, like a whole bunch of stuff just popped up really quickly. And that's sort of, again, this interactive coding environment trying to help guide me to select one of the properties or methods that are available to me on this object. So, you know, if I'm ever confused about like what I can use, what sort of methods or properties are available to me on a string, I can like look through this list to find out more about it. You know, you can also look at the documentation. A lot of the links I have in this notebook are to the Mozilla Developer Network, which is a really great resource for basically any web technology, including JavaScript. But if you're interested in HTML or CSS as well, like they have like really, really comprehensive documentation that's well explained for you know, the syntax rules and like how this sort of technologies fit together to form web apps and websites and whatnot. So it's a really great resource once you're getting into this stuff. Okay. So yeah, like let's actually just demonstrate what I mean by string method. I kind of glossed over that. So like, let's say that we wanted to make my name like all uppercase. We can actually do that using one of the string methods. That is, where is it? Let's forget what it is. Oh yeah, 2 lowercase, 2 uppercase. And so you'll sort of like length, there's like, it comes after this dot, but it's got this extra little set of parentheses behind it. So, so if I wanted to just capitalize the string, I would say 2 uppercase, and then be sure to do the parentheses at the end there. And we'll explain what that's about here in a minute. I can also do 2 lowercase. But so notice how like this doesn't work, right? It just sort of returns this thing F and then parentheses, which doesn't mean a lot to me. It may not mean a lot to you right now. We have to actually use those parentheses to call the method. Okay, so that's, you know, some basic stuff about strings, which again are like one of the basic data types along with numbers and booleans. One of the other things that goes along with strings is this idea of template literals. And so a template literal is basically it's kind of like a string that has like holes in it where you can, where those holes can be filled with like some sort of like evaluated JavaScript code. And so we saw this earlier when we were using that $ and curly brace. We can, and so those were like sort of like what we call string literals. So that's like when we do the back tick and have you know, my name to get the my name value. And so, see, it didn't work because I forgot $ there. And so this is, you know, it's a template because it's kind of like, you know, like a Mad Lib, if you remember that game from when you were a kid, right? It's like a bunch of text with these holes in it that you can fill in with these values. And we can actually, it doesn't have to be like the name of a variable. It can be an expression as well. So if I say my name is James and I am, this is how old I am. I'm 20 plus 20 years old, almost. And so the expression is evaluated, right? And then that value is sort of added into the string. This sort of like template language stuff works with the tick marks. I don't believe it works with the quote marks though. See, it doesn't. Like you have to. That's when you want to use the tick marks, is when you are using sort of string, a sort of template string. Like that's one reason you'd use that versus the regular quote marks. And Observable has like a couple of other template literals that are really useful for us. We've already seen one of them already. It's the markdown template literal. That's when we have that like MD and then tick tick. So MD stands for markdown. If you're not familiar with what markdown is, it's basically a plain text language for writing text that can be rendered as HTML. And it was created by this guy, John Gruber, who is the author of the Daring Fireball blog. He's like the preeminent like Mac fanboy. He also created this thing called Markdown, which is like at this point like pretty ubiquitous, like markdowns in GitHub, in Slack, it's all over the place because people love to write. They want to write in a plain text language that is sort of like transportable into other places, and so Markdown is really great for that. All this, I'm not going to go through all the syntax rules for Markdown, but like here's a few of them just really quickly. When we have a hash sign like that, that indicates that sort of compiles to an HTML like H1 tag. So if I say so like a really big bold type, but subsequent, so this is like H2, and this is H3, and this is H4. So the number of hash symbols like indicates which heading size you want to use. If you don't use those hashes, it's just rendered as a paragraph. So insert in the P tags. You can also do lists in Markdown, either numbered or unnumbered. So if I say, and you can use whatever you want. There's actually several characters you can use for the bullet marks, dashes versus asterisks. But these are rendered in as list items. That's the LI tags. And so, I mean, this is like preferable. Writing in Markdown is definitely preferable than writing in raw HTML, right? I mean, if we were going to do the same thing up here, well, again, we use the HTML prefix to indicate that this is an HTML literal. And then it would be something like, I don't even want to do it. It's like UL, and then slash UL. And then I have to do LI, LI, I did the same thing for the second one, the third one, right? So it's a little bit more annoying to have to type. So that's why, when you're writing text, the sort of like prose that goes around your code snippets and your code output, usually that's going to be prefixed with that MD to indicate markdown, and then you can type whatever markdown you want. Let's see, we're on time right now. I'm kind of racing along here. I've got just like a few more things I want to get through in this notebook. But perhaps it would be a good point to like kind of take a break. I realize I may be like kind of going pretty fast with this stuff. So why don't we just take like 5 minutes right now before we talk about arrays? When I come back, we'll kind of, take a breath, and then if you have any questions at the top, I'll try and answer them before we move on to something else. So is everybody cool if we just like take a quick 5-minute break, grab a warmer on your coffee, or use the bathroom or whatever? All right. Okay, cool. Then I'm going to pause the screen. I'll be right back myself. Okay. That was a little bit more than 5 minutes, but I'm sure we all appreciate the break. I was just trying to respond to some questions I was getting in the QA. I'm kind of getting questions both in the QA and in the chat. To be honest, I'm not very familiar with the QA thing because I haven't done one of these like webinar style Zoom meetings before. I think we're all sort of learning this conference technology in real time. But that seems to work pretty well. So I see people like posting stuff into the chat. Does everyone see the questions when they come in on the QA? Is that a better place to put all this stuff? Can you all see the questions in my answers when I answer them there? Yes, we can see the questions and answers. You can see the questions and answers. We can only see QA when you click on it. Can keep up chat the whole time. Oh, okay, I see. That makes sense. Yeah, okay. I mean, to be honest, it doesn't really matter to me if you guys just, I'll try to keep an eye on both of them. That I will try to answer your questions as they pop up. All right, so I'm gonna keep sharing. Is there a shortcut for moving on to the next cell? Yes, the answer is the shift plus the return key. So if I'm in this cell right here, if I hold shift and then hit return, actually, no, it doesn't move on the next cell. It's actually command plus return, forgive me. It might be control on a Windows machine, so it command plus return. And actually all of these keyboard shortcuts are described right here under this little question mark in the lower right corner. You got the keyboard shortcuts, which you can sort of keep open as you're doing this. Yeah, there's like keys for like moving between cells, merging cells, inserting cells. Yeah, that's very helpful. And there's also some pretty good documentation for Observable. Like some of the stuff that I'm borrowing from as I'm doing these exercises is from this manual and the other notebooks that are out there that are of people like demonstrating Observable's capabilities. Yeah, just check this stuff out. All the resources are out there for your in order to help you. Somebody's asking another question. Oh, sorry, not F strings. I was thinking more about the Python format, the format string. Yeah, I don't know if there is. There might be. Let's actually look. So let's say if I have the string my name, it's probably going to be one of these methods, like I don't see it. I would look in the string methods documentation for something like that. You might find it there. I hope that answers your question. Okay, so we talked about numbers, booleans, and strings, three of the most basic data types for JavaScript. And we talked about template literals, which includes Markdown versus HTML. So now let's talk about a slightly more complex data type called an array. If you're coming from Python, you might know this as a list. It's basically the same thing. It's just an ordered list of items denoted by square brackets. So what that looks like is, sorry, just 1 second. So we could type an array. like this. Array equals, and let's make mine super simple, letter A, the letter B, the letter C, close it with square brackets, and that makes an array. And when you define it, you kind of get this handy little caret for drilling into your array right there in the output of the cell. Just like strings, arrays can have a length. So we can see that by typing, using the same sort of property as we have on the string. So length gives us the number of items that are in the array. And so another thing that's important to know about arrays is that they have this kind of numeric index to them, which begins at 0. So if we wanted to access the first item in the array, I mean, the intuitive thing would be to type array 1, but that actually gets us the second thing, the B, because as I said, the index begins at 0. So like this is 0. A is in the 0 position. B is in the first position, or the second, or the 1 position, and C is in the 2 position. This is something that trips up people a lot, especially when they encounter it for the first time. But it's actually quite common in different programming languages, including Python, to have arrays or lists to begin with a 0. Just like arrays, or just like strings, arrays have lots of methods associated with them for doing like really fancy stuff for like slicing arrays and getting like just sort of before doing lots of like transformations on arrays. So so for starters, let's do let's say we want to get the index position of the B item. So that's for that we would use the index of method, and we would pass in the B string, and that returns us the value of 1 because the B is in the 1 position. We're passing, and so earlier when we called the 2 lowercase and 2 uppercase string methods, we just had these parentheses with nothing in them. But for this particular kind of method, it expects us to pass in an argument. In this case, it's the value of the thing we want to find the position, the index of. So that would be some of these other array methods also accept arguments. So like if we wanted to slice one item from the left side of the array, we could use the slice method for that. And then I'm going to pass in a 1 for that, just the number 1. And so now I get back another array, but this array has B and C in it, but not A, because we basically sliced off that first item. We can also slice from the right, like if we wanted the first 2 items. So that is, or I'm sorry, like the last 2 items, not the first 2. So we're basically saying, just give me another array that contains these 2 items, not the first one. We can also kind of slice from both sides at once. So if I say 1 and then pass in another -1, now I'm sort of slicing off the first item and the last item in the array, and I get a new array that just has the middle in it. Um, if we want to add to an array, we can do that by calling the concat method. So if I want to add an item for D to the array, I would call the concat method for that. That's how we can sort of like append to an array. Append is the method that I'm more familiar with from Python. You know, there's, like I said, you can see how many different methods there are available when you look at, you hit the tab key after you type the dot after an array. You can see like all of the different methods and properties for manipulating arrays. Like we can actually chain these methods together to do even slightly more complicated transformations. So I'm going to do one real quick that looks like this. Like, let's say I had a string, and I'm going to say I put my thing down and split it and reverse it. So that's my string. Let's say I wanted to split it at the white space marks. So now I'm actually splitting not the white space marks, but if I pass in an empty string, I'm actually splitting it every single character in the string. So now I just transformed my string into an array that contains every single character as an item in the that was in the string. Then I can like reverse that, calling the reverse method on the array, and then I can like rejoin it together. And now I get like the same sentence, but like in reverse. So just to demonstrate there how we can chain methods together, and the available methods kind of change as we sort of move from one data type to the next. Like a string became an array that gave us the reverse method, which we then sort of transformed back into a string by calling the join method. That's all I have to say right now about arrays, though it's something we're going to be revisiting a lot as we get more into like doing data modeling as well. Let's see, objects. Okay, so this is like a really hefty concept that we don't have to dive too deep into to be pretty effective. But objects are a concept coming from the object-oriented programming paradigm that's one of the most pervasive in computer science. JavaScript is an object-oriented programming language, as is Python and lots of other ones. And what that means basically is that, like, an object is kind of just like it's like a collection of like properties and methods that model some sort of like useful abstraction for like the computing that we're doing. It's kind of like a data structure on one hand, but it's also a data structure that can like we can like make certain operations available for any sort of like instance of an object. Like if you like are familiar with Python at all, like there's a concept of dicts or dictionaries, and that is like the sort of like object literals in JavaScript are the closest thing to dictionaries. And what those are in both Python and JavaScript are just like key value pairs. And so in the context of arrays, like we can kind of see their utility, right? Like just let's start by like defining what an object. Like one thing that's kind of different about the way it works in Observable is that you know, in vanilla JavaScript, we could just say object equals curly brackets and then like do our key values. So like key key one. So when I say it's objects are kind of like collections of keys and values, those are sort of denoted by the colon. So like this is my first key and this is my first value. And then I'm going to add another key. I'm not doing quote marks around the key names, as you'll notice. I'm just doing them around these values, but the values don't have to be strings either. They can actually be any data type, including a number. So I'm going to do that, for example. So this actually will not work. And the reason is that we have to wrap the whole thing in parentheses. And so now we have an object that is a collection of these keys and values. And we'll see kind of why those parentheses are necessary in a minute. But basically the point is that in Observable, like if we're going to define just a singular object, we can use these parentheses around the curly braces to define the object. And so once we have those, like this object defined, kind of similar to with an array, you know, if we're trying to access these sort of values inside of it, you know, if it were an array, we would use the square brackets to get the sort of value at a specific index position. With an object, we kind of that help us access those values. So let's try this now. Object dot key one. You can even see that my keys are kind of showing up for me as I'm typing here. Key one. So when I do that, I get value one, right? And instead of using like, I actually don't know if this works. Never tried this, but I'm gonna try it right now. This is how it would work in Python. It does. So you can use square brackets as well, but it's actually, I find it much more convenient to use the dot notation when you can, because it's less characters to type. And so, like the sort of the similarity that objects have to arrays is that the things inside of them are indexed. With an array, they are numerically indexed, and with an object, they're sort of indexed according to these keys that we define. And so we can actually get all of the keys of an object if we wanted to return all those. The way we do that is we reference the sort of object type that's available within the scope of Observable, and then use the keys method to get that. We pass in the object that returns for us an array of all the keys. We can do the same thing with the values to get all the values.
And arrays and objects kind of go together to help us describe data, so, or to sort of model data. Like, let's say we had some data that included the observations of hours of sunshine and precipitation in each, in a few like major U.S. cities. The way we would do that in JavaScript is we would use an array. So use it, so square brackets like this. And then inside the array, we would use a bunch of objects. And it's because they're not at the top of the cell, we don't have to use the parentheses here. We can just say city, Seattle, and then annual hours, sunshine. I'm not typing this from memory. I'm looking at some notes from somebody else's notebook. 2163, and then annual precipitation is 37.3 or 0.13. And so like that's this is basically an array that contains one object. If we add a comma, we can actually add more observations for other cities. So like New York, and then 4, 6, and I'll do one more, Chicago. Okay. So now I've got an array with 3 objects, and this is roughly the equivalent to like rows in a spreadsheet or in a table, for example, because we've got the keys are kind of like the column headers, and then you got your values. That's the sort of like key value structure of the objects. Somebody's asking questions. This is probably because I'm not a heavy data user, but I'm feeling a little lost in the weeds of the coding. When possible, I'm hoping we can take a step back to understand the bigger picture outputs will look like, so we can understand what these different coding items feed into. It's very great observation. And yeah, like it's, we're just trying to get through like some of this basic syntax stuff so we can get on to some of that more interesting stuff. I recognize that people are like kind of coming from like different levels of experience. What I'm hoping to do is kind of put everybody on like a similar playing field in terms of the syntax, so that we can kind of talk about the more interesting stuff about how we interact with data and visualize it. But we'll move beyond this sort of like these really like rote rules here in a little bit. But I just kind of wanted to like throw some of this stuff out there. I don't even want you all to feel like you have to memorize the things I'm doing right now. I just want to like kind of give you some context for things that we're going to demonstrate in a little bit. Like if it's not obvious yet, like I don't have this stuff memorized because nobody really does. Like there's a lot to keep in your head when you are a developer. especially one who like works in many different languages. And I'm not somebody who does that all the time, right? Like I'm actually more interested in like doing journalism. And so when it comes to like figuring out how to do stuff, I'm often like find myself like on Google and on forums, like asking people questions and looking up stuff. But what I'm hoping to do right now is kind of give you a little bit more of like a guided walkthrough of like the syntax. It's not a comprehensive walkthrough, and like it's definitely not like everything you need to know in order to like do observable stuff. But yeah, we have like I think three more major things to talk about with the syntax rules, and then we're just going to like move on from that and actually make some charts. So somebody's asking, are objects the same as dictionaries in Python? And the answer is yes, pretty much. At least the way that we defined it up here as like sort of an object literal. We can actually, you know, in Python, you can also define classes and then like create instances of those classes, which are also, I mean, that's sort of like, those are also considered objects as well. You can do that in JavaScript too, but like we don't, we're not going to need to really do that in order to do some of the stuff we're going to do. So I'm just kind of skipping over that. Like if you want to get a deeper dive into JavaScript, there's lots of really awesome stuff out there. Like the, like I said, the Mozilla Developer Network is a really great resource. And like lots of really awesome observable notebooks that I'll add to the resource list as well. Okay, so we talked about just now about objects and how we can sort of like include them as like items within an array to sort of make a sort of like table-like data structure, which is something we're going to see a lot. But now I want to talk about something else called functions, which even if you're not familiar to programming, like if you're somebody who uses like, if you're like one of these like Power Excel users, you know what a function is basically, right? Because like you know about how you can write that like in a given cell, like equals, and then like say it's, you know, sum, and then like parentheses, and like add a bunch of values together. Like that's just a function, right? And in JavaScript, we have some of those those same built-in functions, but we can also define our own functions. And really a function is just like, it's basically like a procedure, you know, some statements that all sort of run to perform a task or calculate a value. But what makes it different from just like a regular cell is that we can reuse it over and over again. And we can also like provide inputs to it. That's kind of the main thing that makes it different from like a cell, is that idea of like passing parameters or arguments into a function to change the output of it. Let's actually define a function real quick. Like, let's say I wanted a function that would calculate the percent change. So, you know, if you've, you know, done this kind of calculation in Excel before, you know that like the formula for calculating percent change is that it's new minus old divided by old. So let's actually just write a function that does that really quickly. The sort of longhand way is to use the function keyword and then give it a name. So I'm going to call mine percent change. And then I'm going to define my arguments as new and old. And so that's, then I use curly braces, which is where the body of my function goes. Like this is sort of like, this first line sort of declares my function, what I want it to be called, percent change, and what I want my arguments to be. And the curly braces are sort of set off all the things that happen in my function. And usually you want a function to return a value, so use the return statement for that. And so to do that, we're going to just write another expression, which would be new minus old. And then actually, I don't think, I'm just realizing I don't think new is going to work because it's another keyword in JavaScript. So I'm just going to use the shorthand N and O, N and O. We have to be careful about the names we choose for our functions, our arguments, our variables, if those clash with the keywords of the JavaScript language. So new divided by old. I'm going to, and then I'm even going to multiply the whole thing by 100. So this like defines my function, and which doesn't actually execute it, right? Like in order to execute the code inside the function, I have to invoke it. And the way I invoke it is I just like reference it and then pass in the arguments. So let's say 150. Yeah, so that's a 100% change when I going from 100 to 50. That's sort of the longhand way for defining a function. There's also a kind of shorthand that's sort of new to JavaScript, and you'll see it a lot in these data science notebooks, which is called an arrow function. The way that an arrow function works is we just kind of leave out a lot of the sort of explicit stuff and keywords. So I'm just going to do the same function as an arrow function, which will be, I'm going to call it %change arrow. And then I'm going to set it equal to, the way it works is you use the sort of equal sign plus the caret sign to sort of, so it looks like an arrow. That's kind of why it's where it gets its name. Then we basically do the same I'm sorry, I'm getting this a little bit wrong because one thing I forgot is we have to add the arguments at the beginning as well. So if we say NO for our arguments, and then the same sort of expression that we had up here. And now if I do the same invocation, it should have the same result, right? It's just kind of like a shorthand, right? It's a little less explicit, but basically what it's saying is like, I want to create a function that has %change arrow. The arguments are these two things. And this is what the body of the function is going to be like. This is what it's going to return. This kind of makes even more sense when you're talking about creating functions that don't really have many arguments to them. Like a good example is, let's say we wanted a function that would return the precipitation of any item in our data. Let's just do that real quick. That looks like is precip equals d D stands for like datum here, and then so it becomes this sort of like shorthand for the thing that gets passed in, annual precipitation. And so now I can say precip, and then I can pass in like data, like the first item in my data array from above, which should be, yeah, and it'll be different for different items in the array. There's not really a lot of difference between functions and arrow functions other than how their verbosity. There are some like other kind of quirks, but like it's really not that relevant to what we're going to be doing. Again, like if you're interested in like more of the details and the difference between like arrow functions and regular functions, like just check out some of the docs I've referenced. Okay, so I mentioned a couple other things I wanted to, there's just like really one other set of like syntax rules I want to introduce, which is the imports, including require and import. I mentioned earlier that like, because, we're working in JavaScript, we have access to like lots of really awesome software packages that do really cool stuff. Which means we don't have to write as much code as we need to make interesting visualizations or do data wrangling. If you've ever, I think a lot of people have heard of D3 if you're at all interested in data visualization. It's like like this really popular JavaScript library for doing like really cool interactive visualizations. If you ever sit down and try to learn D3 and like write code using the D3 language, it's a challenge. Like the learning curve is like kind of steep, and I feel like I can say that with confidence because I've gone through a few instances of learning D3 and also like using it in a professional capacity. And if you're not using it constantly, like it slips away pretty quickly. The package has like the D3 library has evolved a lot recently, so that now it's kind of like more modularized, so we can like just import like specific pieces of it that we want to use. So like a good example of that is the D3 array package, which just gives us like more methods for doing stuff with arrays that we don't have out of the box in Observable. So the syntax for importing one of these software packages is to use require, the require keyword. So I want to like create a variable sort of named cell that's going to be called D3, and so set that equal to require. Sorry, I'm spelling here. D3 in quotes. So that's require parentheses quote D3. And so now this is like all of you notice like all of these functions and a whole bunch of other stuff that's actually being hidden. This is like the entire D3 package, but I can actually just get one piece of it called D3 array, which is all I really want right now. And so now I have functions like for counting, for getting a cumulative sum, for getting groups and getting the max value of an array. So let's actually try and use this real quick. Like if I wanted to get the mean annual precipitation from my data array that I defined up here. So like the basically the mean value of these three things. Here's how I can do that using D3 array. So that would be D3 equals, I'm sorry, D3 dot mean, that's the method. And I'm going to pass in the array itself. And then for my second argument, I'm actually going to pass in an arrow function, not explicitly like defined previously, because I want to show that that's something we can, that is possible, and you'll see a lot like d dot annual precipitation. And so that there's our mean value. We can do the same thing to get the max value or the min value. Data, and then D, and then D dot annual precipitation. And then we get a max as well. I'm just going to do it quickly here by copy and pasting, just showing that all the change is the method itself. So, you know, this is like not that impressive with like only 3 items, but you can imagine like an array of like, you know, thousands or even millions of items in it. Like being able to compute that value pretty quickly is quite handy. Okay, so so requiring is using the require keyword. It basically imports the package from something called the node package manager, which is like a package manager for JavaScript packages. So like if you're from the Python world, like npm is basically the equivalent of pip, PIP. But this observable is basically just like going to this package manager and importing that code into the notebook. We can also import from other cells in other notebooks. Or sorry, we can import cells from other notebooks. Here's what that looks like. Like there's actually a one like really impressive set of observable users are the folks who work at the University of Washington Interactive Data Lab, and like they've got a lot of really awesome tutorials and really cool analysis that they use that they've done in Observable. And they've also have these like utilities for you know, just kind of doing stuff like reading data or looking at data and manipulating data that we can use as well. And so like this is a notebook that contains some of those utilities. So they've got one defined up here that's just called print table. And so it's defined right here. It's this giant function here. And so we can actually import that cell into our notebook and use that with our data if we want to. Here's what that looks like. I'm going to import print table first. And I'm going to do that by using the import keyword. And then I'm going to say in curly braces the name of the cell that I want to import, which is print table. And then from, and then @UW data. That's the name of the observable user. And then the name of their notebook, which is data-utilities. And actually I need to just remember to put this part in a string like that. And so now I have import table available to me like in my notebook. So if I type import, I'm sorry, not import table, print table. And I can call print table with my data. And so now instead of like having it in that array, I can have it in like this like nice sort of like readable format. And there's actually, this is one of like many sort of print table utilities I've seen. And it, you know, tables can be a valuable visualization form as well as just as valuable as a line chart or a bar chart in many cases. And so I always like keeping one of them handy when I'm trying to like read through data or, you know, sort of make data into like a really presentable format that we can show to people. That's kind of all I wanted to get through with the JavaScript or observable syntax. Like I said, we barely like scratched the surface of JavaScript, but we don't really need to get that deep into it in order to use observable and to use the charting libraries we're going to use. And so, you know, that's kind of one of the things that I find really exciting about the technology and the open source software that and the communities around those things that exist right now is because, you know, we have people who are really, really smart and really, really dedicated and doing really cool stuff that they then share with everybody else. And we can all sort of pick up and use because, you know, as journalists, we care less about writing software than we do about like producing journalism. And so that's one of the things I find very exciting about like stuff like Observable and like all the things that sort of is able to connect us with. Does anybody have any questions about any of the syntax stuff we've gone over before we sort of move on to something else? Let's see. Okay. So I asked the question, are we going to get to how to connect these functions to existing data sets and spreadsheets? And yeah, the answer is yes. You can actually upload your data sets and attach them to a notebook if you want to. So like if you have like a CSV file that you want to use in analyzing Observable, you can do that. Now we'll show you how. I think somebody else just asked another question. I found that sometimes the tick didn't work and I had to use single quotes. You just gotta be mindful of like sticking to like one versus the other whenever you're defining a string or a string literal. The tick marks are really only useful when you're doing some sort of like literal. And so you might find you just want to use quote marks most of the time, except when you know you have like a string where you're going to be like adding values to it before you render it. Okay, so I've got another tutorial I want us to do that kind of demonstrates some of the really cool like sort of reactive features of Observable. And I promise, like, you know, a lot of you probably showed up to like talk about like covering the COVID pandemic, and I really want to talk about that stuff too. This is going to be like the last non-COVID related exercise we're going to do. So if you're feeling a little impatient to like get to the meat of this workshop, then I'm just asking to please be patient. I'm just going to keep moving on unless anybody wants to take a break or anything. Okay. Okay, so the thing I want you to do right now is to go to this notebook here, which I'm going to drop in the chat. And then fork that notebook, which is what I'm going to do right now. So again, I'm going to the top here. I'm going to say fork. And now I have my own sort of version of this notebook that I'm going to edit. Let's get going. So basically the idea in this exercise, we're going to demonstrate how you can use the await and fetch keywords to get data or content from an existing web API, and then to sort of show you how like sort of further like demonstrate some of the reactive elements of Observable. So what we're making here is basically just like a tool for like getting dog pictures, which is a lot of fun, I think. And this is basically one of the tutorials from the makers of Observable that we're just going to go through right now. So the first step is just like being able to like get a dog picture. And so in order to do that, we are going to use this thing called dog.ceo, which is like an existing API that just gives you dog pictures. If you're interested, you can actually submit your own dog's picture to this repository of dog pics, and maybe you will even see it show up in one of their API calls. I put my dog's picture in there just the other day. And so what they have is this endpoint called reads/image/random, which will just return you a dog picture of a random dog and breed. So if I point my web browser to that, what I get is like a link to a JPEG file that for a specific dog. And so anytime I go here, you'll see that it's like a different breed, a different identifier for the picture. Let's actually do this ourselves in our notebook. So we're basically just going to do kind of what the notebook says up here is we're going to get we're going to use the await keyword and followed by fetch, and then the URL for a random dog pic. And so if we just do this, what we get back is a response, a response object. And so, fetch is the thing that makes it sort of returns you a promise to get a response, and that's what that sort of await keyword is used to do, to like signal that we're making a sort of asynchronous call to this API. It's like we don't expect it to like immediately evaluate. We're going to kind of wait for a response before like this cell gets evaluated. And so if we just call it with just the URL, well, like I said, what we get back is this response object, and within that response object is a JSON function or method, and so we can just do this, which will get us back which gets us like the JSON part of the response, right? So that includes that sort of link to that URL for that specific picture. So now that we have that link to that picture, we can actually render that using the HTML tag template literal that we talked about earlier. So what that looks like is just, again, HTML, then 2 backticks, and then we do an image tag, so that's an img tag, and then src equals, and then we have to do quote marks, and then close the tag. And then what goes in here is the message part of the dog variable, which is the JSON part of the response. So if we say dog, $, curly braces, dog dot message, then we get a picture of a very, very cute dog, very cute indeed. And so, again, this is just showing how we can use, we can sort of render HTML using this sort of HTML literal syntax and sort of like pipe in values from our JavaScript code. Now let's do this next part, which is to get a list of like all the possible breeds of dogs that we could be sending requests for. So in order to do that, there's a separate endpoint on this dog.ceo API that has a list of all the possible breeds. So let's do this part real quick. So now I'm going to start a new cell called breeds, and I'm going to, again, use await because I'm fetching, which is going to return that promise of a response, not necessarily a response immediately. And then I'm going to pipe in the and get the JSON back. Pipe in that URL so I can get the JSON. And so if I look at this now, in the message part, here is this is the message key is an object that contains a key for every breed. And then for each breed, it looks like it would be an array of I guess like sub breeds, right? Bulldog, Boston Bulldog, English, French, whatever. Did not, yeah. So it sort of has this sort of like nested structure to it. So now that we have all the breeds, we can actually use those to create like a selector for selecting which breed we want to send a request for. So we sort of saw something similar to this with the sliders earlier, but a slider is just one type of like input element. Another one is like a select or like a drop down. And just like we saw with the print table utility, there's actually some really helpful utilities for doing inputs that were created by this guy, Jeremy Ashkenaz. And we can sort of import those from his notebook into ours. And so to do that, I'm just going to, it may already be, it's not already. I'm sorry, we're just going to import that right here. Import select from at jash commands / inputs. And then now we can do a view of breed, which will be a select. Select is being like a kind of a type of HTML element. And get object keys. Or actually what we want to pass in here is the breeds, I believe. Oh wait, no, that's right. We're gonna get all the keys out. That's what we're doing. So object, get all the keys of the breeds dot message object that we got back from our response. And so now, look, we got a little drop down here with all of those, dog breeds. So now we just kind of need to connect this to the thing that gets us the picture to sort of make this tool for like being able to like just select a dog breed and get a random dog. One thing that's worth noting here is that we can actually, in typical JavaScript or Python, everything like sort of executes sort of from the top to the bottom, but it doesn't work that way in Observable. We can actually modify the order of things by dragging cells and reordering them, and it doesn't change the output at all. Each cell is kind of its own independent script, and so the order matters less than like the kind of like dependencies between the script between the cells, and that's why like this legend over here is like really super useful for being able to kind of figure out like how things are connected. And they do a pretty good job of like showing you like, well, breeds is referencing something that is from this import statement, which is also referenced in this cell or whatever. So it's a good thing to pay close attention to that. All right. Now what was I going to do next? So we've got basically the only thing left to do is for us to, like I said, modify which breed we put into that URL to sort of change our dog pick fetcher. So what I'm going to do is I'm going to take where's the, yeah, so this thing that returns the picture here, this part right here, I'm going to I'm going to move these cells further down. Sorry, it's going to scroll rather slowly. And I'm going to put it right there. And I'm going to go back up here and change the part where I was fetching the dog pick to do something different. We actually just need to add in this extra level to the URL. And I think that's all we need to do to change it. Let's see. So if we add this part right here, I think that's it. Oh, that wasn't it at all. What am I missing? I'm just going to copy the URL to make sure I get it right. Here it is. Okay. Yeah, and so now I'm getting an affin pincher, but I can select an Airedale or a Beagle or a Rob Bancoon or a mix. This is where you might find my dog someday. Oh, that's a sweet one. We could just do this all day if y'all want to. I don't care. This would be fine with me. It's kind of therapeutic in some ways. A Labrador. Those are chickens. What are we looking at chickens for? It's not a dog. Okay, so, but you know, one of the points here that I'm trying to get across is that, you know, we are looking at, we're working in an environment that is like not just interactive but reactive. So we don't have to like run the cells in order to see things change. It all just happens for us. And that's like one of the things that makes Observable distinct from these other computational notebook environments, like Jupyter, for example, where like the order in which the cells have run matters. This, I feel like, is one of the things that really sets Observable apart, because in some ways it kind of begins to feel more like an interactive environment akin to a spreadsheet, because like you can sort of change data in one cell and see it cascade immediately to all the other places that depend on that cell. You know, I know that like the syntax stuff was probably a little bit difficult to get through, but like I really do feel like if you're someone who uses Excel a lot and you are familiar with writing like all of those like super complicated like nested formulas, you can do this stuff too, because it's really not that different. Like it's just a slightly different syntax that's going into these cells. Any questions about like Observable and like the stuff we went over before I move on? Things are running a little bit later than I had expected. Like I did want to talk a little bit about Vega before we break for the day. And even like at the very least, like make a simple bar chart. There's really a lot to unpack with Vega, so I think we don't have enough time to really go over it in depth. I don't want to leave us all hanging, waiting for making some more interesting chart stuff. All right, I got some questions here I need to get to. Are there going to be? Yes. Will this be recorded? It is being recorded. Yes. I have been trying to learn, so I feel like I can follow along, but I always get stuck at JSON or working with APIs. I'm not even sure what I want to make so it makes sense. It seems this is weird. Okay. All right, cool. So like very big question, and like I totally get where you're coming from about like APIs, because like the term itself is like super confusing, and the way people describe it only confuses you even more. Like, you know, I wasn't always you know, kind of steeped in the vernacular of code. Like I, at one point, was just like somebody who wandered into a tech company as an English major with no background at all in technology, and like people were talking this weird sort of jargon all the time to me. You know, it took a lot. It took some time to like sort of get up to speed. But just to answer your question about APIs, like it's best described in terms of like an interface, right? That's what the I stands for, application programming interface. So if we think of like other interfaces, like a graphical user interface. That's like what you see on a screen, right? Like a web page or an application that you can like point and click, right? So you can interact with the elements on the screen in order to sort of drive that software. With an API, you have to use a computer language to interact with that software. But both things are just interfaces, right? Another metaphor I hear a lot when people are describing APIs is like, if you think of like the wiring in your house, like as a system, like the electrical system in your house. That electrical system has certain like endpoints, which are the plugs, the wall sockets where you can plug something in. Like those wall sockets are kind of like they're kind of like the API endpoints. It's the things that you can like, it's sort of the surface of the system that you can interact with, as opposed to the internals of the software. And so, APIs are often, one we were just using as a web API, right? So it's like, we're able to manipulate it or interact with it by making web requests, like using the HTTP protocol to like get data from an endpoint or send data to an endpoint. But a web API is only one kind of API. But one of the APIs, and I guess we should just go ahead and kind of talk about it a little bit right now, since we are already there practically, is the Vega Lite API. I'm going to save a lot of this for tomorrow because we're running out of time. It looks like people are having to dive off. But Vega Lite is also an API that we can use. Not a web API so much, but it's a library, a software package that has that we can write JavaScript to interact with to draw charts for us. And it kind of just like summarizes a lot of the work and the operations of drawing a chart on a web page, and puts it into like more concise grammar that we can use. And so, thinking of like learning code and computer languages in terms of language, I feel like is a really super helpful framing for learning this stuff, because then it's really just all a matter of like learning some syntax rules. And as journalists, we're pretty good at that kind of stuff, especially if we're like print journalists or web journalists. Like if you write a lot, like in like a lot of copy, like you can write code. Like I feel like especially people who are really good at copy editing can be like really good coders, because you've just got to learn some syntax rules and follow them. And what's nice about the Vega Lite coupled with the Observable notebook is like the amount of syntax you have to know is pretty limited in order to do some cool stuff. We're kind of at the 2-hour mark here, so I feel like this is about the time we said we were going to break. We actually got a little over. Didn't quite get through everything I wanted to get through today, so I apologize for that. I'm going to kind of revisit some of the stuff I have on the slate for tomorrow and scale it back a little bit. But like one thing I want to ask you all to do before we regroup for tomorrow, like I've got some specific data sets related to the COVID pandemic that I want us to work with. But if you have something a data set that you want to work with, or even just like a chart that you want to try and make, please send me a note. And then we'll try and work on that. We'll try to at least give you the space to work on it and some support in doing that. The way to do that is to just, I'm just going to put it up on the screen here. I'll just drop it in the chat real quick, my email address. Where's the chat window? So Gordon J at RJIonline.com. Yeah, just shoot me a note. And I'll also mention that for the in the sort of resources section, wait, this is not it. Where I get, yeah. At the sort of end of there of the slides here, there's a couple. I've linked to a few data sets that we can use. But if there are other ones people know about that are like quickly available, we can work with those as well. So yeah, you might check out some of these, and we'll talk a little more about what they are tomorrow. Thank you all for sticking with it, and I'm really looking forward to coming back tomorrow morning and really getting into the nitty-gritty of making charts. I think it's going to be really exciting, and I hope to see you back tomorrow. Thanks so much, and goodbye.